Hello, welcome back to the industrial pharmacy classes. In today's class, I'll be discussing about the tablet press, its various uses, its components, and how it's going to be used for the manufacturing of tablets. The tablet presses are basically classified into two categories. One is single punch tablet machine. The second category is rotary tablet press. This is the 16 station tablet press. And coming to the single punch tablet machine, this has a single station. It has a one single punch set. So one punch set here means the lower punch, the die, and the upper punch. These three tools put together is termed as one station. So as there is one station in the tablet machine, it is termed as a single punch tablet machine. So this is mostly used for academic purposes. And coming to the rotary press, this has more than two stations. You can say more than two or six stations is termed as rotary press or a multiple station tablet press. So here this is one of the pictures which depicts 16 station tablet press. That means this is a tablet machine which has a 16 stations or 16 punch sets. Likewise, there are different categories. Like you have 32 station, 42 station, you have at the minimum level from 8 station, 10, then you have 12, then you have 42. Like that, you have more number of stations increasing based upon the required output. You can able to choose the number of stations. But the 16 station tablet machine is the most versatile one for producing or manufacturing tablets in large quantities. Now, let us see the various parts of the tablet machine. So, in this picture, if you see here, this is the side view of the compression cycle. In this picture, you can able to see the upper punches. These are all the upper punches. And if you see here, the number is being found over here, 6, 7, and 8. These numbers represent the punch station. For example, if you consider this one, this is a punch set 6 at station 6. Okay, this is punch set 7, punch set 8. Likewise, you can able to find out the based upon the number, you can tell at what station that punch set is. So in later cases, you can able to identify if there are any problems are arising, then you can able to identify at a particular station the problem is arising. Okay, that is about the punch station numbering. And if we see this is the feed frame. So the main purpose of the feed frame is to hold the granules in firm position. So here this is the feed frame, and if you see these are the upper punches, and if you see here there is a track over here where you can see the movement of the upper punches, and here it is coming down and it's coming under the roller and moving back. So the punches are guided by this track. This track is known as cam track. So the main purpose of cam tracks is to guide the movement of the punches. Similarly, in this picture, if you see the lower and upper cam tracks of the upper punches, can you see here? These are the upper punches. This is the lowering or lower cam track. These punches are coming under the roller, and again the punches are lifted up by the upper cam track. So this is the lower cam track, upper cam track. So the punches are coming down under the roller and moving back to its original position. So here at this point, what is exactly taking place? Under this roller, the tablet compression is taking place. Can you see here? This is the point where the tablets are compressed. Can you see here the upper punches are in the die pocket? So here compression is taking place, and at this point, the tablets are ejecting. Can you see the series of tablets are emerging out of the machine? So here, this is the point where exact compression takes place. Coming to this picture, also you can see very clearly, see the granules are filled here in this pocket, and see the compression of tablet taking place here, and here the compression state, and here the tablet is compressed, and it is about to eject from the die, and you can see here a series of tablets emerging out of the rotary machine. And if you see this picture, exactly showing how the tablets are ejected. See here, compression taking place here, and the tablet has been ejected out of the die. Can you see how the tablet is exactly on the punch tip and is about to emerge out of the die? So you can see here the tablets are emerging one after the other in a serial manner. So here in this picture you can able to see exactly the compression, ejection and tablets emerging out of the machine. Now let us see the various parts of the lower punch. So basically the punch has a stem portion. This is the stem portion, and this is called the barrel of the punch, or otherwise it is called punch body. And here this is called the punch neck, and below that you have the punch head. So here on the whole you can able to say that any punch possesses a punch head, a punch neck, punch body, and punch stem. And at the tip you have a punch tip. The main purpose of punch tip is to give the desired shape of the tablet. For example, in this case, the tablet is round in shape. So that is why you're having a circular tip. If in another case the punch is maybe having some other shape in the form of a triangle or in the form of a capsule shape or in some star shape or in a different shape. So thereby what happens is the punch tip is going to vary, and ultimately the punch tip differs from punches to punches depending upon the shape of the tablet. And the main purpose of stem is to give the desired strength to the punch tip, and ultimately the punch body gives the ultimate power to the punch, entire punch. And the punch head and punch neck are mainly responsible for moving the punches. For example, let us say the head portion has an outer diameter and an inner diameter, where it exactly coincides with the cam tracks. So the cam tracks are exactly going to guide the punches by means of this punch head. Now, if you see in this picture, this is about the lower punch. Now, if we take the upper punch, then how it is going to differ? The stem portion is going to differ. The length of the stem in lower punch is little bit bigger, whereas when it comes to upper punch, it is shorter. So ultimately, what you can able to say, for lower punches, the stem portion is bigger, and whereas for the upper punches the stem portion is smaller, or you can say shorter. That is how you can able to differentiate between upper punch and lower punch. Now let us see the various parts of the die. The main purpose of the die um, is to hold the granules in this bore and to go for compression. And this is a solid die. Yes, this is a solid steel component which has a good number of, I mean, you can say it has some weight, and this die is mainly responsible for giving the shape of the tablet. So the punch tip will exactly coincide with the die bore and it will align with the lower punches. So all the tip of the lower punch, the die bore, and the tip of the upper punch, all these three will align together in a single line to give the desired shape of the tablet. Now coming to the parts of the die, can you see here this flat surface is called the die face, and the central hole is called the die bore. So the die bore is the place where all the granules gets filled into the die bore. So thereby what happens is this die bore is a tunnel like device which is grooved in the die, and the granules get filled from here to the bottom of the die. And there is can you see a shining line like a thing over here? Can you see a shining thread like a line here? This is called the chamfer. This chamfer exists between the die bore and the die face. So what is the main purpose of chamfer? The main purpose of chamfer is to give an easy sliding of the tablet away from the die bore and to make the tablet to exit easily from the die bore onto the die face, and from there the ejection blade ejects the tablet onto the collection chamber. So the main purpose of chamfer is to give a sufficient room for the tablet to exit out of the die bore. And coming to this point here, this is called the die groove. The main purpose of the die groove is to fix the die in firm position. Once the die is placed in the turret, and by means of Allen key, that Allen key passes through this die groove. Once the Allen key passes through this die groove, then what happens? The die will be fixed. So the die will not rotate once the compression machine is in a full motion. These are the parts of die. So what are the different parts of die? Die bore, die face, and chamfer, followed by die groove. These are the parts of die. Coming to this is the technical diagram for the die. Whatever I've said is over here. Can you see here? This is the die face, and chamfer is the small turning curve like device. Portion is called chamfer, and from here to here it is called the die bore, and from here to here this is the outer diameter, and if you see here, this is the inner diameter, and this central portion is called the die groove. So this is the technical diagram how you have to write in your exams whenever they ask you for the technical drawings of punch tooling. Coming to this picture feed frame. So the main purpose of feed frame is to hold the granules in ports. Can you see here? These open places are called ports, and this feed frame has a network like device. It has two blades. One is ejection blade, and the other one is the scraper blade. The main purpose of ejection blade is to eject the tablet from the tablet machine. And the main purpose of scraper blade is to remove the excess granules and to bring it back to the normal ports again. And the main purpose of ports here is to hold the granules in firm position. Thereby, the granules will be moving from one port to another port from the base of the frame in the form of a small thin thread like device. And the entire feed frame is bolted here with nuts, and the feed frame will be fixed onto the turret. Once you are fixing the feed frame onto the turret, you should be very careful in maintaining the gap. So the gap between the feed frame and the turret must be a paper thickness. So a paper must be moved comfortably between the feed frame and the turret. That is the exact gap that should be maintained in order to prevent spilling of the granules from the tablet machine. That is the important aspect you have to take into consideration whenever feed frame is fixed onto the turret. Now, let us see the lower cam in this picture. In this picture, you can see here, this is the lower cam track. Can you see the small pockets, circular like pocket? These pockets are mainly responsible for holding the upper punches. Can you see here? Punch stations. Punches. So this is a 16 station. So 12 here, 13, 14, 15. So like that you have all the numbers. So this is the punch station 12. And here this pocket, can you see these pockets? These pockets are designed on the turret. This device is called the turret. So the turret consists of dice. So all the dice are placed over here. And as I told you, through the die groove, see, can you see this Allen key? Yes, if you tighten this Allen key, and here, can you see the gap over here? So the Allen key passes from here to here. Thereby, what happens is the die will be fixed firmly. So all the Allen keys are here, and the die is placed over here. The upper punch is placed over here, and below the die, here you have the place for lower punches. So all the lower punches are placed over here. So the lower punch, die, and upper punch will unite together to give a punch station. And can you see this framework as I discussed in the earlier slide? Can you see this steel frame is called the feed frame. So what is the main purpose of feed frame? The main purpose of feed frame is to hold the granules. So where the granules will be held, can you see here? This is the port. So here the granules are placed. Similarly, you have one more port over here. Likewise, you have some other ports on the other rear side of the machine. And if you carefully observe the feed frame, can you see here there is a small opening over here at the bottom of the feed frame. Through that opening, the granules will be moving from one port to another port in the form of a thin thread. So the excess granules are scrapped by this scraper blade, and the granules will be in intact position. And can you see here? These two are the oil cups for where they are filled with oil, and they give subsequent lubrication while the tablet machine is in manufacturing process or in operating process. Coming to this picture, this picture depicts hardness adjuster. Can you see the lever here? This is the lever which is mainly responsible for increasing or decreasing the hardness of tablets. Suppose if you hold this lever and turn in clockwise direction, so this raises up. When this raises, the hardness increases. When you move this lever in anti-clockwise direction, so the hardness decreases as this lever here makes this tool to come down. So in this way, the tablet hardness can be increased or decreased by moving this lever either in clockwise direction or in anti-clockwise direction. So this is the hardness adjuster. Similarly, you also have one more device which is at present over here for fill volume adjuster. Now, so that fill volume adjuster will be somewhere below here, somewhere you can able to see. Okay, but the fill volume adjuster is not seen over here, but you can able to see the hardness adjuster. And here you have the motor, and this is the roller fixed to the motor. Thereby, this roller makes the compression machine to rotate. So this is about the hardness adjuster. Coming to this picture depicts the hopper. The main purpose of the hopper is to hold all the granules or the entire blend which needs to be compressed into this steel device or steel container, which is known as hopper. So the hopper consists of a cylindrical vessel with a conical bottom and still with a narrow conical end, and the edge of the hopper is called the chute. And here can you see this glass window which is known as a sight glass to see how many granules are present in the hopper, or to know the quantity of granules remaining in the hopper. And can you see the screws over here? These two screws are mainly responsible for fixing the hopper. So by using this screw, if you turn in clockwise direction, you can able to increase the height of the hopper. If you turn in anti-clockwise direction, this hopper comes down. So thereby what happens is the gap arrangement between the chute and the turret is regulated. So here the gap must be of thin paper like distance. So the thickness of the paper, how much will be the thickness of paper? That much gap must be present between the chute of the hopper and the turret. And can you see the roller over here and see the other parts? This is how the hopper looks like. And now you have known what are the important components of hopper and what its main purpose for. Now let us see the tablet compression cycle. This is the picture which is giving you the complete process. So whatever parts which I have explained are present in this slide. Can you see here the upper punches are slowly guided by the upper cam tract white colored lane track is called the upper cam track. So when the cam track when they are following exactly the white colored track. So the upper punches are guided by the upper cam track, which is nothing but the white colored track. And so the punches are moving in horizontal, coming down below the pre-roller, and again moving under the main compression roller, and they are lifted up and again moving back to the original cycle. Similarly, you have one more cam track at the bottom. Can you see this white line? This is the cam track where the punches are guided. You see here, the punches are moving horizontally. They are coming down and they're coming onto the fill volume. And here the granules are being filled. Can you see the orange colored granules are being filled at this point? Excess by this scraper, and the granules are being see the lower punches are coming below the pre-compression roll. What happens is primary compression will take place. That means what? The granules which are filled into the die, they get compressed first. Then further, the compressed will move under the main compression roll. The main compression roll will give more hardness to the tablet. Thereby, the granules become more compact, and it results in a solid dosage form. That is the tablet where it is being produced, and can you see it is emerging here. So once it is emerging, what is happening? Until here, they are coming onto the lower punches are coming onto the pre-compression roll, then onto the main roller, then they are slightly raised over here. So once they are raised, what happens is the tablet which has been compressed is lifted up by the lower punches. So that is why the orange color tablets which are produced over here, they are coming onto the turret, and they are easily ejected by the ejection blade of the feed frame, and the lower punches again moving back to normal cycle. So here you can able to see all the components of the tablet machine which I have explained. Now let us see the real working of this tablet machine. So this is the 8-station tablet machine, which I have been giving a demonstration to my students which are working in International Medical University, Kuala Lumpur. And here, in this picture video, you are seeing how the tablets are being manufactured in lab scale for academic purposes. As I told you, you can able to see that this is the turret. Can you see the dark black color? What they are the die Allen keys, okay? And can you see here? This is the weight frame. Can you see the movement of the upper punches by the lower cam tracks? They're coming under the roller. See how they are coming, guided by the upper cam track. Can you see here this portion where the granules are placed into ports? Can you see the ports? So each port is being filled with the granules, and can you see this is the feed frame, which is in brass color. Can you see the hopper? See the scraper blade is removing the excess granules over here, so that the granules are exactly filled into the die pockets. And here exactly the compression is taking place at this point, and see how they are emerging or ejected from this end. Can you see here? The tablets are slowly being ejected by the ejection blade, and they are being collected in the collection chamber. So here the tablets are being collected into the sieve, so that the tablets are de-dusted simultaneously. Thereby you get a polished tablets. So this is how the entire working of tablet machine takes place. So subsequently we'll see some more topics in next class. Thank you, and we'll continue in next class.